So we've got a little bit of a post bag today. It's really freezing in here, as you can probably tell from my hands. It's about 12 degrees, which is weird because I think it might be warmer outside. Anyway, the first thing I've got to show you is this. These are some Rolson wire strippers. Now these are a really interesting kind. Usually I use these type, or I just strip them with a pair of pliers like this and just do it a bit gingerly, but these ones seem really awesome. And I put them on my Amazon wish list. And Kevin McCallier said, love the ESP8266 videos, enjoy your gift from Kevin, which honestly, it made my month. So I was really pleased. Thank you very much. I don't expect anyone to buy anything from my Amazon wish list. I literally put it there just in case any of you are secret millionaires. So I get by fine. I don't need anything, but I really appreciated the gesture. So thank you very much. Well, more than a gesture, it was great. Anyway, let's get started, shall we? So I haven't covered up the addresses on any of these, so we'll be opening them upside down. This one just says module adapter, value of $5 US. So let's get this one open. I've ordered quite a few things recently, so I don't really know what's arrived or not. Technically, according to the website, nothing should have arrived. So what is this? They're probably all kits. Right, well, oh my Lord, this is something I've really been looking forward to. And I've seen other people do it on YouTube, and I've really cursed myself for ordering it so late because I really wanted it to arrive. This is a little Tesla coil. I don't know whether it really is a Tesla coil or if that's just a cool name that people give it, but it should play audio. So we've got our little coil here wrapped in some lovely toilet paper. So there we go, that's that. And so that's going to be a little Sunday kit, a dangerous Sunday kit, I think. I'll pop all that away and then we can move on, but that's exciting. I'll put a link in the, actually I won't, I'll wait till the Lazy Sunday episode and then I'll put a link in the description for you. But for now, that should be pretty awesome. I don't know, oh, that audio jack is for the music that it can play. That's pretty cool. Next up, we've got one from the UK. This one, I know it's from the UK just by the label on the envelope. It is a little mini wireless adapter. And I want one of these for the little TV project. Where did that thing go? I've put it somewhere. But I'm going to strip all the internals out and solder that directly to the Raspberry Pi Zero. I've seen someone do it. I saw an article on Hackaday, I think, and they'd taken out the internals and soldered it directly with wires to the PCB because it has the micro USB, kind of USB on the go thing. So I thought that would be a great addition and a really, really small form factor. So I'll be giving that a go. I've already got a couple of these, but I didn't want to destroy the ones I've got because they work really well. Next up, we've got another one, but my address is all over it. So I'm just going to open it slightly over here. I had to go and collect it from the post office. For some reason, they made me sign for it. So there's nothing else in there now. But it's tiny. It could easily have fit through my letterbox. Oh my word, these are brilliant. So I ordered a bunch of these SK6182, I think they might be. They're NeoPixels, essentially, the same kind of thing. This is going to make a horrible noise. I'll cut this bit out. So they're like NeoPixels, but they're a different kind. I'll put a link in the description for these, but these ones have a black surface. They're a very small, in fact, let's zoom in a little. These ones they're very small, so these aren't the 50/50 kind. These are a different form factor. I can't, for the life of me, remember. So I will, I'll put it up on screen or in the description so you can find them. But they're really tiny, like a NeoPixel. So you put data in one end and it comes out the other and goes to the next one. So you can address them. So they're addressable LEDs. The same with these ones, but these are slightly larger, so these are your normal size. And these ones are warm white, white and cool white, I think. And so they're all white pixels, and so they're not intended to be coloured. But it gives you that, it can give you a graduation of white, essentially. So it's possible you could do some kind of sort of warmth in and out kind of fading, which is hopefully what I'd like to do. And I bought 100 of each. And I think there should be some more floating about, but they haven't arrived yet. So there are still quite a few more to go. This is, oh, this is cool. Do we have a tab it? We do. So this is a little Bluetooth audio adapter board. So you've got micro SD to play audio through it, but it also has Bluetooth on board. So I picked this up because I thought it looked interesting, but also it was really cheap. So I'll pop a link in the description. I thought I could remake some of the old boombox type stuff that I used to do before. So it looks like you've got power in on the USB. You've got an audio jack in. There are some buttons here for mode, play, next, back, and EQ. So maybe it has some kind of functionality there. And we've got either micro SD or you can plug a USB flash drive into it. I'm not sure about the connectivity with the USB, with the Bluetooth, but we'll have a play with it and see if it's worthwhile. A couple of headers here. I'm not quite sure what they're for. It may well be that those are the speakers. I can't really see any of the pins on there, so it's possible that's what they are for. We'll play with it though, so this is not in depth at all. Next up. Of course. I fancied making my own ESP8266 board, and so I picked up one of these adapters to see if it would suit my needs, because it won't have any of these extra LEDs on there or anything else that's going to drain power. So I really wanted it to be as low power as possible, and because I'm working with the ESP8266 wireless temperature sensor, I thought, do you know what, maybe I should start making my own board. I'm happy playing around with hardware that I've already got and trying to make it as low power as possible, but it might be time I designed my own with a more simpler board. And this will be a starting point for that. So eventually I'll design my own board and get it printed, but for now we're going to be playing with one of these. I've got another one here. One of these days I'm going to cut my finger. I dare say this is probably a kit. Yes, it is. Oh my word. I love getting kits. I mean, I love designing my own boards and everything. In fact, we're going to be getting a board come through from PCBs.io soon. And that's going to be the LED clock that I designed, which is kind of like this clock, except mine's a really crap version of this clock. So that one will be a fun one. It uses a matrix of LEDs. This one, oh God, this is the awful one. It's going to be an LED heart. So doesn't that look brilliant? So it comes with some cables. We've also got an IC on here. So I don't really know what it's going to do, whether it's going to rotate the LEDs or not, but it'll be fun to find out. This one's been hanging around for a few days actually, but I didn't want to open it just in case some more came in and we could do a post bag. What have we got? It's wrapped fairly well. It's a bit jingly. Oh my word. This, I've been waiting for some of these to come in. I accidentally ordered a few of these. This is an LED matrix and it's sort of a spectrum analyzer. So we'll be soldering LEDs onto there and we've got the microchip on the back. And I was really drawn to this because it's not too far away from the LED clock that I designed. My LEDs are much smaller and packed into a smaller space, but this is essentially the same size as my PCB is going to be, and it's going to have a clock here and then the controller stuff around the outside and on the back. I wonder what chip it uses. Let's find out. Well, it's just bare in there. That's nice. So it uses a little STC chip, and they're based on the, what is it, 8080 or something like that. I can't really remember, but that's interesting. That's what the clock that we had an STC chip in it. I wonder if we can see that on the back there. Yeah, it did. It had an STC chip in there too. This is still working, by the way. So we've got various other components in here. We've got the USB, we've got a little, ooh, look at this. If you can, hopefully we'll be able to see this. This is exciting. There's a small ball of something in there. I think it's mercury. Can you see that? It's very difficult. Maybe if I turn it over that way, it'll be easier. So it's like a tilt switch with a mercury ball in it. I mean, it looks like mercury. It behaves like mercury, so I'm going to guess it is. I wonder what that's for in terms of this circuit. Anyway, we shall find out. I'll pop these away. So that is a mostly SMD kit, so that should be fun. It'd certainly be a long video when I do that. I picked up one of these, but I'd already opened it, so we'll just take it out of the packet now and we'll just talk about it quickly. But I'm approaching 10,000 subscribers. Not that I'm really into the count exactly, but I found this little 7-segment display with 8 digits, and it's based on the Max 2719. Is it? No, Max 7219. And I thought, you know what, I could get that hooked up to an ESP8266 and get the subscriber count showing. That would be easy enough. It's a little bit wonky, but it has these mounting screws and everything, so I thought that'd be quite nice. But, you know, if I get round to it before 10,000 happens is another question. But it looks fun all the same. I'll put a link in the description. I think, actually, that was kind of expensive because I bought it in the UK. I think it was probably £5. Because I wanted to get it pretty soon. Almost the last one. I've got this, which is an AV to HDMI adapter. Now, I don't particularly need this right now. All it does is take the composite signals, so your video and your left and right channels, and then turns it into an HDMI output. Now this thing was kind of expensive. I think it was around £10. They're all kind of expensive. You can't really find anything for under 8. And I bought this in the UK, so it was kind of expensive. But playing with the ZX Spectrum, I want to be able to plug that into an HDMI input rather than the composite that I can get from over here somewhere, potentially. I don't even know if it works, but if it does, I want to be able to put it into an HDMI input. It's an interesting little one. You can get cheaper ones which are HDMI to composite, but this is they're only one direction, aren't they? So you can't use them either way around. So the input to HDMI output are more expensive. Now we've got the very last one. It's quite a large packet. I already know what it is because I sort of had a bit of a feel. It's another kit, but this one is kind of cool. So let's zoom in a tiny bit, but because it's so massive, I don't really need to zoom in very much. So this is one of these persistence of vision things where you wave the wand around. So you've got these are red LEDs in here, and we've got a microcontroller down there. No doubt it's one of those STC ones. Let's have a quick look. So this will be another kit build, but also possibly inspiration for something of my own. I'm really fascinated by point of view, persistence of vision, not point of view, idiot. By persistence of vision stuff. So I know that you can flash an LED at a certain rate and then you won't really see any perceptible difference. No, it's an Atmel chip. So we've got, let's zoom in a little bit on that. So it's an AT89SS oh no, S52, that's all, 24 PU. What else have we got? What's this thing? What the devil is that? Does anyone know what that is? Oh, actually it says something on the side there. MHKG. Is this a thing do you shake? I don't really know. I don't know. Where would it go? Oh, over here, S1. So it must be a switch of some kind. So does it, oh, I see. If I flick that, you can see it move inside. So it's like a tilt switch, but a bit different. So this wobbles around inside and is the switch on the end of this. So it detects when it's going back and forward, I guess. That's interesting. This should be a fun one to put together. I hate these crappy LEDs. I might see what the circuit's expecting in terms of forward voltage and that, and maybe change them up for a white LED or something similar. So that is it. That is the entire post bag. So thank you very much for hanging around. Have I got anything else to tell you? We've got loads of projects coming up. The ESP8266 is still on the go, obviously. I'm just trying to find the correct MOSFET to turn it, to turn the microcontroller on. Currently, I was trying to use a BS170. However, because of the nature of the MOSFET means there's a voltage drop across the MOSFET, so it won't work. It drops too much voltage, so we're going to have to look for a different solution. So it just means finding something that's a bit easier to use. It's going to have to be a logic level MOSFET that I can throw, say, 4.5 volts into and get around 4.5 volts out. But it isn't the easiest thing in the world. So I'm going to ask my my electronic engineer friends, which is you. So please feel free to tell me if you know of a good MOSFET that I can use to turn the ESP8266 on and off again, because it will signal the ATtiny85 to say whether it's going to turn on, say whether it has finished, and then it will turn off. So yeah, I just need to find something good for that, I think. Otherwise, the ATtiny85 bit of the circuit is done and works really well. Goes down to 6 microamps is what it runs at, which is less than the quiescent current of the voltage regulator that's currently on the board. And I know you guys say, why don't you use a different board with an HT7333 or whatever? Well, I've already got one. One of these is, it's got one of these tiny little HT7333 or whatever the chip is actually called. However, lots of people don't have these, and lots of people are stuck with the ones with the ASM 1111111117s. And I would like to try and help them out by figuring out a way we can just turn it off completely and have a low current microcontroller like an ATtiny85, or even lower current than that. Turn these on and off again and have a bit of functionality as well. So I haven't yet implemented the analog sensing of the battery yet, but I don't think I really need to just yet, because the ESP8266 is doing that for me. Anyway, thanks a lot for watching. This has been a mammoth video, so I will speak to you all soon. Goodbye.